Welcome. Today, we're diving into a problem that affects literally everyone, from hardcore gamers to massive international airports. How do you connect a bunch of computers so that everything just works?
All right, check it out. You and your friends are all geared up for an epic gaming weekend. You've got the laptops, you've got the snacks, but how are you going to connect all those PCs so the network doesn't lag out and die right when you're about to clutch the win? It's a way bigger puzzle than you'd think.
So this whole arrangement, the way you lay everything out, it actually has a technical name. It's called the network's topology. And trust me, getting that topology right is the secret to a network that doesn't make you want to pull your hair out.
All right, so before we got to the super fast, reliable networks we have today, people tried a few things that, well, let's just call them learning experiences. Let's meet some of the clumsy ancestors of modern networking.
Okay, so first up, we have the bus topology. The idea was super simple. You've got one main cable, they called it a backbone, and all the computers just kind of hooked into it. Kind of like people getting on a bus. Sounds easy enough, right?
Yeah, not so fast. See, the huge massive problem with the bus was that if that one single backbone cable broke, like anywhere along the line, the entire network just died. Poof. For that gaming party we talked about, that's an instant game over for everyone.
Okay, so back to the drawing board. Engineers tried another idea. The ring topology. Now this time, each computer was connected to its neighbor, forming a complete circle. Data would just pass along the ring from one computer to the next until it got where it was going. Seems pretty neat and tidy?
But you guessed it, it had pretty much the exact same fatal flaw as the bus. If even one of those connections between computers went down, the circle was broken. The whole network would just grind to a halt. One little broken link, and that whole circle of trust is just shattered.
So yeah, it was pretty clear that engineers needed a much better idea. They needed a hero to save the day, and they found one in a design called the star topology.
Now this is the big one. It's hands down the most popular kind of network you'll see today, everywhere from your house to your school. And it's so simple, you can actually draw it with me right now. You ready? Okay, step one, just draw a box right in the middle. That's our hero, the central switch. Got it? Cool. Now step two, just doodle your devices around it, maybe a computer, a laptop, a printer, whatever you want. And for the final step, just draw a line connecting each of those devices straight to that switch in the center. And that's it, you just drew a star network. See? Easy.
Now that little box in the middle, the switch, that's the real magic here. Think of it like a super smart mail sorter. When one computer sends out some data, it goes to the switch first. The switch looks at the special address, it's called a MAC address, kind of like a unique house number for every device, and it sends that data only to the computer it's meant for. This is way smarter than an old device called a hub, which would just shout the message out to everyone on the network. Super inefficient and not very private, you know?
Whoa, wait, so you're saying if my cable gets unplugged, it's just me that disconnects? My friends can keep playing? Yes! And it's easy to add someone else, and it's faster because the switch is like a traffic cop? Okay, this is a game changer. This is awesome.
But, even heroes have an Achilles heel. Since every single device is connected to that one central switch, what do you think happens if that switch decides to, well, permanently take a coffee break? Yep, the whole network goes down. It's still a single point of failure.
So to solve that problem, for situations where failure is just not an option, we have to look at our final contender, the mighty mesh network. This one is designed from the ground up to have no single weakness.
Okay, so there are two flavors of mesh. First, you have the full mesh, and the idea here is kind of extreme. Every single computer is connected directly to every other computer. It makes this crazy web of connections. Then there's the much more practical version, the partial mesh. Here, most computers have a few different connections, but they're not necessarily hooked up to everyone. It's a really smart compromise.
Whoa, hold on. A full mesh? So if I have 5 friends over, every PC needs a cable going to the other 4 PCs? That is a ridiculous amount of cables. My room would literally look like a spaghetti monster exploded. That sounds super expensive and just nuts.
Exactly. It's not practical for a gaming party, but the massive, huge advantage here is resilience. In a mesh network, there is no single point of failure. If one path breaks, or even a whole computer, we call it a node, goes down, the data just says, okay, no problem, and finds another way to get there. It is unbelievably robust and reliable, which is why it's used for really important
All right, team, it's showdown time. We're putting our two main heroes, the star and the mesh, head to head. Let's throw them into a real-world problem and see which one comes out on top.
Okay, here's the scenario. An office at an airport needs to connect 5 computers and 2 printers. They need it to be reliable. So should they go with a star topology or a mesh topology? What do you think is the right call here?
Okay, let's really think this through. Reliability is key in an airport, for sure. But a full mesh for just 7 devices? That's total overkill. The cost and complexity of all those cables would be way too much. A star network, on the other hand, is much cheaper, it's simple to set up and manage, and it's still pretty darn reliable. Yeah, the central switch is a potential point of failure, but for a small office like this, the star is absolutely the most practical, cost-effective choice.
But let's go back to that idea of a super resilient network. One with tons of different paths, no single point of failure, a partial mesh, but on a massive global scale. Does that sound familiar at all?
Because that's exactly how the internet works. The entire thing is basically one giant, sprawling, partial mesh network. The original idea came from a network called the ARPANET, which was designed to survive a major attack. All the big routers that shuffle data around the globe, those are the nodes. And it's why if a deep-sea cable gets cut, your video doesn't stop. The data just finds another way to get to you, and you probably never even noticed. It is the secret to the internet's amazing resilience.
So there you have it. We went from these clunky, fragile bus and ring networks to the smart and efficient star, and finally to the incredibly robust mesh that literally powers our entire modern world. It really makes you think, though. If the internet is the ultimate partial mesh we have today, what's the next giant leap in connecting our world?